Hi friends, welcome back. Today we're talking about finding the area of a trapezoid using special right triangles. Now, aka reference triangles. Now, if you're familiar with reference triangles, what I want you to do is you can skip the first part of this video. You're going to scroll until you see this big sign, area of a trapezoid using special right triangles. And then at that point, you know that the lesson is beginning. For the rest of you who don't know special right triangles or reference triangles, I'm going to start by giving you a quick refresh of that. Now, let me just tell you, you do need to know these for trig. So even though you're just in geometry right now, when you get to algebra 2 and when you get to trigonometry, you're going to need to know your special right triangles. So I don't want you thinking like, I thought when I was your age, like I can totally just use trig and figure this out. Why does it have to be exact? No. Learn your reference triangles. Again, let me repeat that. Learn your reference triangles. Okay, so we're going to start here first. You do need to grab your notes. I do want you to write this down. First thing that we're going to do is talk about a 30, 60, 90 triangle. And here's how this works. You have a 90 degrees triangle, a right triangle. It has 30, and then the other angle has to be 60, right? Because it adds up to 180. Here is how we do this. Opposite your 30-degree angle is your M. Your hypotenuse is double that, so 2 times M. Your other leg is M root 3, and I remember 3 because there are 3 different sides in this kind of a triangle. So again, opposite 30 is M, your hypotenuse is double that, this is M root 3. The reason why I say this is because these are based on a ratio, and I think it's a lot easier if we do it this way. So the other one, so write that down. The other one we have is a 45-45 triangle with this 90-degree angle here. This one's a little bit easier because it is M, and then the hypotenuse, as opposed to the leg in this one, is M root 2. And I remember 2 because there are 2 sides that are the same. Remember, a 45-45 triangle is an isosceles triangle. And if you have 2 angles that are the same, then the sides opposite those angles are also the same in a triangle. My definition wasn't rocking there. Okay, so let's talk about how we practice that. Here, for example, I have this guy right here. We'll start with that one. I'll cover this up so we don't confuse you. So we'll start with this guy right here. I see it's a 30, 60, 90 triangle. So I'm going to put my 60 in here. Here's what you do. You take 30, opposite 30 is your M. Your hypotenuse is double that. And then this is M root 3 because there are 3 different sides. That's not actually why it's 3, it's just how I remember it. So what we have here are 3 equations. We have 3 equals M. That's this one right here. We have y equals 2m. And we have x equals m root 3. Okay, so now we know 3 equals m. Well, if that's the case, we use basic substitution and we substitute that in. Y equals 2 times, and instead of m, I'm going to plug in 3. Y equals 3. Or y equals 6. I don't even know how to multiply. So we now know that this guy, this y over here, is 6. Okay. Now over here we have x equals m root 3. And we know our m is 3. So it's 3 root 3. So this side over here is 3 root 3. Now I use m for my variable. You can change that. I just don't use x or y if you're solving for x or y. Use a or something like that if there's an m already in the problem. So let's try this one. Okay, 30, 60, 90 triangle. Opposite 30 is our m. Our hypotenuse is double that. And the other one is m root 3 because there are 3 different sides. Now, I've got 3 equations here. I have x equals 2m. X equals 2m. I have y equals m. And then I have m root 3 equals 3 root 2 over 2. Now this looks a little tricky. The only one that I can solve here is this guy over here because these have 2 variables, so there's nothing I can solve for there. I'm trying to get this m by itself, and in order to do that, I want to divide by root 3. And if I divide by root 3, that cancels out, and divide by root 3. So now I have a complex fraction here. I have m equals 3 root 2 over 2 divided by root 3 over 1. Remember, we never divide fractions, we multiply by the reciprocal. So m equals 3 root 2 over 2 times 1 over root 3. Okay, so now what we have is m equals, actually, let's do this over here. Multiply straight across the top, we get 3 root 2 over 2 root 3. Now, in this case, we can never have a radical in the denominator, so we have to rationalize. Multiply this by root 3, multiply this by root 3. So now I have 3 root 6, 3, and then multiply underneath, root 6. Now, root 3 times root 3 is root 9, which is just 3. So 2 times 3 is 6. And from here I can simplify. Divide by 3, I get 1. Divide by 3, I get 2. So my m is root 6 over 2. Okay, so now that I know that my m is root 6 over 2, I know what y is, because y is just m. So y equals root 6 over 2. Now, for my x, it's 2 times my m. So x equals 2, and I'm going to put it over 1 since we're dealing with a fraction. Root 6 over 2. All right, well, looking at this multiplication problem, I can cross cancel those out, and I'm left with root 6 over 1, or just root 6. So we can come back up here and we say, okay, x, this guy's going to be root 6. This y is going to be root 6 over 2. And then this guy over here we already have. So now we know. That's a complicated one. Usually they're a little bit easier like this, but notice at no point did I turn these into decimals. You cannot turn reference triangles into decimals unless you're told you're allowed to. But the whole point of a reference triangle is to keep them as the accurate numbers. So let's try another one. So these are 45 triangles. Okay, so remember opposite, so this is going to be m, this is going to be m, and then this one is going to be m root 2. Okay, I'm going to be honest, I didn't realize I forgot to write the problem in there, so I had to go look that up really quick. This guy equals 9, so that would have said 9 here. So we have, if this m equals 9, remember this is an isosceles triangle, this m also equals 9. And so if m equals 9, this side over here is just 9 root 2 because we substituted in for our m. Okay, so let's look at this guy. We have on these, remember our legs on our 45 are just equals m. So once I find out what x or y is, then the other one is the same thing. This guy equals m root 2. So we've got to do some simplifying here. We have m root 2 equals 8. Divide by root 2, divide by root 2. I get m equals 8 over root 2. But again, we're never allowed to have a radical in the denominator, so we have to rationalize. Multiply by root 2, multiply by root 2. M equals 8 root 2 over, because 8 times root 2, just 8 root 2. Now root 2 times root 2 is root 4, which is just 2. And you think you're done here, but remember you can cancel out. Divide by 2, I get 1. Divide by 2, I get 4. So my final answer, m equals 4 root 2. So that means my y equals 4 root 2. So these sides over here are going to be 4 root 2. So that's a quick refresh, quick and dirty refresh on reference triangles and some of the more complicated versions of it. Okay, so area of a trapezoid using special right triangles. Area of a trapezoid using special right triangles. I'm leaving that there for the people who were scrolling. Okay, so now that you've scrolled to here, we're going to take a look at example number 1. Example number 1. So a quick refresh on finding the area of a trapezoid. You do the base 1 plus base 2 divided by 2 times the height. Okay, really quick, I want to back up and just talk about the area of a trapezoid right quick. So here's a trapezoid here, okay? I know these squares are a little bit difficult to see, especially because I have it on white paper. But if I were to ask you to find the area of this, we have 1, 2, 3, 4, 5, 6, 7 up here. 1, 2, 3, 4 over here. So the area of this rectangle that I have here is 7 by 4, which is 28. Now, if you take a look here, I'm going to take this guy right here, and I'm not leaving the screen with it. I'm going to put it right there. I have not removed anything from this rectangle that we already determined had an area of 28 degrees. But now you can see that I have a trapezoid, but I haven't removed anything. So the area of a trapezoid is still just the base times the height. However, you can't play favorites with your base here. See, this base up here has 1, 2, 3, 4, 5, This one has 1, 2, 3, 4, 5, 6, 7, and like almost 8 of one. So you can't play favorites. So what that means is, let me get rid of this bit here. So for example, I have a trapezoid that looks like this. My height has to make a 90-degree angle. That's super important. So there's my 90-degree angle. But let's talk about the bases. Let's say I have this is a base of 10 and this is a base of 14. Well, and then my height is, let's say, 5. Well, in a rectangle, it's the area of the base, or I'm sorry, it's the base times the height. And it's the same thing here, except we can't use 14 because that's not fair to 10, and we can't use 10, so that's not fair to 14. So we have to make a compromise. And the way that we do that is we do like a little mini average. We add the two together and divide by 2. So 10 plus 14 divided by 2, that gives us 24 divided by 2, which equals 12. Do you see how 12 is right in between 10 and 14? So it's a compromise, right? So that's where we get the area of a trapezoid. Okay, so with all of that said, let's go back to this problem. So looking at this problem here, finding the area of this guy is going to be, we're going to add the bases together and divide by 2, and then we're going to multiply by our height. Now, they're trying to trick you here by giving you, they, me, whatever, by giving you this 22 on this slanty bit. That's not your height. Remember what I said, it has to make a 90-degree angle. So our height is this thing right here. So we need to figure out what that height is, which is right over here. And so I've taken this triangle and I've enlarged it here, and conveniently it is a 30, 60, 90 triangle. It's 30, 60, 90. So remember I said opposite your 30 is your A, or your M, sorry. Your hypotenuse is double that, so that's 2M. And then this guy is M root 3. Now, I just need to figure out what my H is. Well, my H equals my M. If you take a look over here, so I have 3 equations here. Sorry about that. I have 3 equations here. I'm moving the paper all on you. Let me get this out of the way. So we have 2M equals 22. We have H equals M. And then we have this other one, M root 3, but I don't care about that because we don't need to figure that guy out. So if I look at this, I divide both of these by 2. I get M equals 11, which means H equals 11. So my height is 11. So now I'm in a position to be able to find the area of this trapezoid. Almost called it a parallelogram. You've got to know our shapes around here. So in this case, the area is going to be area equals the base 1 plus the base 2. And so let's slide that back down. 32 and 48. So 32 plus 48, whatever that is, we're going to divide it by 2, and that's going to give us a nice compromise between 32 and 48. So if we've got 32 plus 48, that's 80. I don't know why I had to use a calculator for that. What's going on? And then we're going to multiply that by our height, which is 11. So our area is 80 times 11. And so just so that we have this, I was going to rewrite it like this. 80, we're trying to find the area. Oh, these were inches, by the way. Okay, so inches. So we have 80 inches times 11 inches. That gives us 880 inches squared, or squared inches squared, inches squared, that kind of thing. So you've just got to be really careful with your reference triangles. And please, if you have any desire to go into Algebra 2 or Trig, you need to learn these reference angles or reference triangles. It will make your life a whole heck of a lot easier. So let's dive into a problem that's a little bit more difficult. All right, so we've got example 2. We have Kethra wants to paint her mom's deck. The dimensions are shown below. 1 can of paint covers 72 feet. 72 feet squared, I should say. What is the area of the deck and how many cans of paint are needed? Okay, so let's take a look here. Again, we're going to need this guy and this guy. So we're going to need a bit of information here. Okay, so the height here, I'm going to take this triangle and draw it out like this so that you can see it a little bit better. All right, we know this is 60, which means this other one is 30. This is 18. And so this is going to be our height. But for right now, what we'll do is I like to use a separate color when I do these. So opposite 30 is our M. Our hypotenuse is double that, so that's 2M. and this is m root 3. So we have 3 equations here. We have, and I'm sorry, let me back up and call this our h for our height. So that's our height right there. So we have 3 equations here. We have 2m, so 2m equals 18. If we divide by 2, we get m equals 9. So that means this guy right down here is 9. Now that we know our m is 9, we have 9 root 3. So our height is 9 root 3. So why is this important? Well, we have the height, that's good. Now right here, we also know that this is going to be 9 as well, because this is 18 feet and this is 18 feet. So that means that this is 14 down here. So let me redraw this trapezoid for you. Here's our trapezoid. And what we know is, let me use this black one over here. Okay, so we know this is 14. And then just to make sure I've got this, we've got 9 plus 14 plus 9, we've got 32. And then we have 9 root 3 for our height. So to find the area, we take the bases, add them together, and divide by 2. So area equals 32 plus 14 divided by 2, whatever that number is, we're going to multiply it by our height, which is 9 root 3. So we take 42, that's 46 divided by 2, so that's 23. So area equals 23 times 9 root 3. So to leave this in exact terms, we would say 23 times 9 gives us 207. So our area is 207 root 3, and we're talking about feet squared. That's our exact one. Now, you don't have to leave things in exact when you're dealing with word problems where it makes sense. What is the area of the deck? Well, if I tell you it is, let's use a different color here. If it is 207 root 3 feet squared, you're going to be like, that's kind of a weird number. So instead, we're going to take 207 and we're going to multiply it by root 3. And so when we do that, we end up with approximately 358.53 feet squared. So it covers 72, each can of paint covers 72 feet. So we need to take this 358, we can round it to 359 to be honest, divide that by 72. So if we have 359 and divide that by 72, we end up with 4.98. So 5 cans of paint would be needed. So 5 cans of paint would be needed. The area is 358.53 feet squared, and 5 cans of paint are needed. So hopefully that helps explain those reference triangles and finding the area when we've got a side missing. We'll see you next time.